All right, last person entering for this session about Apache Metron and how Qsight has implemented this. My name is Michiel van Tilburg. My co-speaker is Bas van der Lustgraaf. And well, we will tell you about the journey we have been making with Metron, with Hortonworks, and the lessons we have learned so far. First, tell you a little bit about the company we work for. That's Qsight IT. It's a product of a merger of two companies, of Qi ICT and Qsight ICT. Qsight is mainly focused on cybersecurity, selling security devices like firewalls, and we also have our own SOC, and we do have a managed services had to service the devices which are at customer site. So we are a security service provider in that way. And Qi ICT was selling hardware for networks and like storage and all kind of devices. 2016, the merger took place, and recently we are acquired by KPN, which is a large telecom service provider in the Netherlands. Bas and I both work at R&D team. We have a mix of all kind of specialties like DevOps, BI, that's my my specialty, big data, and data science as well. Should point there. So that's where we came from. This is a sketch of our current architecture. We use it from a commercial software vendor. I'm just setting the scene a little bit for me. How many of you have experienced with this kind of security platforms? 1, 2, 3. All right. So maybe I should explain this a little bit. Going from left to right. At left-hand side, we have a sensor, which is a nifty little device, so to say, which collects all kind of data from all kind of network devices, gathers that, stores that, and passes them through to this security engine. And inside this security engine, there's some built-in logic, which says, evaluates the data it receives, like saying, okay, this is suspicious, could be a possible threat, or not. So the logic is built into this security engine. At the end, somehow, this security engine has decided it should be processed further on. So a SOC engineer should take a look at it because it's a possible threat, and take a look at it now because it's very dangerous, or whatever, something is happening, you should intervene just at this moment, or you can do it later. So it's maybe a possible threat. Data is also landing somewhere on reports, landing on dashboards where we give insight into the customer, what is happening on their network on a weekly, monthly basis. So far, so good, right? So what's the trouble with this current architecture? Like I said, the security engine is more or less a closed box. We don't exactly know what is happening inside. We are not able to expand or enhance this logic with our own logic. That's one. All data is processed by a smart sensor. That's very nice, of course, but not all data is coming through. So this system decides for us what is relevant or not. We would like to decide it for ourselves, what is relevant or not. So we would like to have more insight into what is happening with that data, and we can influence that ourselves, right? Another thing is that if we add more customers, we add more like silos. So it's a silo. For every customer, its own architecture. So what happens if we want to apply rules, whatever, security rules, for all the customers? Copy, repeat. And so that's not very easy to maintain. And of course, every time we connect a new customer, we have to buy a new license fee. So all these things together, we decided some 2 years ago that we should get something else. So enter this new platform. You see, of course, some things returning and some things are enhanced. So we have still the sensors on the left-hand side gathering all kind of data, but we are now able to apply other sensors, apply different devices. And so we want to have all kind of security devices because we don't exactly know what is at customer site, right? Because the customers, our customers, they ask to secure their network. So what do you have in your network? We have this firewall, or we have this whatever device. And to a certain extent, we can advise or maybe force the customer to say, well, just don't use that, but you better use this. But in the end, there's still the customer decision, right? So we have to be able to be adaptable to all kind of devices. So with this architecture, we can do that. That's why we developed a probe. That's what we call a probe. It's some device you can stick into the data center of the customer, and that collects all that data. All that data is flowing through the probe, and we collect all that data. That data is sent through from whatever's over here to our platform, to our Metron, and this is Metron in the middle, via Minify, NiFi. So in the end, then it ends up in our platform, and in the platform we do different steps. We parse that data, obviously, but still we don't know what's over here. To a certain extent, we don't know. And if the customer says, maybe there's another device you can connect, can you also collect that data and process that data? We have some kind of parsing framework where the engineer who has to connect that device is able to do some modification, and then the parser is writes itself, right? So it's without coding, you can connect a new device. So we enhance that within Metron. Now we enrich the data with some location, where is it coming from, and also with specific data we get from the customer, because we maintain the customer CMDB asset database, which has its host name, IP address, obviously, and all kind of additional data we append to the data which is coming from the network. An important thing we enrich there is the asset risk level, and we use that in the end to, in the triage, say what should we do. So we enhance the data with, like data which is about the asset for further processing. How does this works? I will talk in a minute about that. So that's obviously in the threat intel step, we decide based on, how do you say that, signatures, what is happening, because this is all data without meaning, so to say. It's just data coming through, and over here we say, okay, is this a threat or not? And the same we had on the previous slide in that security engine, saying, okay, is this something suspicious, or is it just whatever data which is perfectly okay, which is perfectly normal, right? How this works, I will tell in the next slide. And the alert triage, I will tell also about that in the next slide. And in the end, then the data is stored, gathered in HDFS, so we can do all kind of, how do you say that, statistical analysis on that, make some reports on it, make some dashboards on it, and it also lands in Elasticsearch for real-time searching and for real-time dashboarding. Threat intel. What is it? Just to give you some idea. On the lowest level, we have the sensors, right? So, and they gather all the data, which is obviously meaningless. It's passed through and saying, okay, is this suspicious or not? Is this a threat or not? So the data hits, so to say, a signature, yes or no. If it does, then we have to do something, right? And these signatures, there are 10 to 20 to 30 to 40,000 of them, so there are a lot of signatures, which is not easy to handle in the end. So we group them together, these signatures, we group them together into detectors, which is a collection of signatures describing similar threats. So that's one layer on top. On top of the detectors, we group that together into directives. And these directives say to the SOC engineer, what should you do? So that gives a hint or a use case or a runbook or whatever you want to call it, saying if this and this and this is happening, you should do this and this and this. Call the customer, do whatever, hit the fire alarm, or that kind of stuff. And from 10,000 or maybe thousands and thousands of signatures, we come to around 40 to 50 directives. So we in this case, we have too fast, right? A sensor, which is, in this case, in this example, is a Suricata, which is a network intrusion detection system, which gives us all kind of data about what is happening on the network and if is somebody or something entering your network. So in this case, it hits a signature, which is called black hole exploit pack, whatever, which is detector, which is a exploit kit. And there are a lot of exploit kits, but this is one exploit kit. What should you do? This is a malware infection, and for a malware infection, we have a runbook, right? So you come from all these technical stuff, what is happening, you get a direct hint to the SOC engineer, what should you do? Is that clear? You may ask questions, right? No? Okay, since this is kind of technical, and we are trying to target as well the more management or C-level of a company to make security a business driver, we added in the end another layer to get into real business risk, into real business talking. And therefore we said we have an implementation layer for the sensors and the signatures. So that's really the technical implementation. How does it work? Based on either these Suricata signatures or own set of signatures you can write yourself based on whatever policy or whatever threat you want to investigate. On top of that, we had the threat layer. So remember, there were the directives and the detectors. We grouped saying this is the threat layer, describing more in business terms or generic terms the real threat. And on top of that, we added a business layer, which is directing business risk. And the business risk can be B2B non-compliant to laws and regulation. Could be a business risk, right? A business risk can be discontinuity. So if your vital systems are attacked, if your vital systems are down, then you have a real danger. Like in a hospital, you're not able to operate. In a manufacturing system, you are not able to manufacture whatever your car or whatever you are manufacturing. So that is a real business risk. Financial loss, in the end, is a consequential risk, of course. And we have this nice example from Facebook, like, what do you say that? Reputational damage. And so it's not good for your reputation that your data is out on the street or whatever, so you are not a trusted company anymore, and so that's a real business risk. So what we did is we tied these directives to a business risk, and then you can talk to a risk manager or whatever to say, okay, what kind of business are you in? What is your biggest risk? And we can pinpoint all other layers and saying, okay, so we have to be very aware of this and this and this and this and this detectors, and then like cascading out to these signatures. All right, yeah, you're all quiet. So that was that one, and like I said, I promised this alert triage tab. We also enhanced that, or we did something to it. Continuing the example, like the exploit kit, that's a risk 10, right? Well, very dangerous, just for the sake of the example, right? And it's found on a laptop from the CEO. Wow. And we give this asset, in this case it's just an asset, right? We give that a value, in this case a value 10. So this goes into the equation, and then saying, okay, we classify this as a critical infection or critical event, and mitigate and notify customer immediately in this case. But what happens if this same exploit kit is found on whatever test laptop, which is somewhere in the corner, dusty, doing something? Then it's not that bad. So it's the same infection, but on a different asset. So this asset is evaluated as value 1 or whatever. So we classify it as an informational, do nothing at this moment, notify this customer somewhere in a monthly report saying, oh, also we had whatever 100 of these classifications. Maybe we should do something about it or not. And if it's not, then we can completely rule out this test laptop. Whatever is happening, you will not be notified anymore. So we call it whitelisting, saying, okay, you whitelist this laptop, and then it's on the whitelist list, and we will not be notified. So we enhance this kind of system in order to give the end customer some real insight in what is happening on their network. And also, he's not bothered if was not happening, and this was valuated as a 10, or if it was valuated equally like that laptop from the CEO, then he will be called middle of the night, right? Saying, okay, this laptop is on fire, you should do something. And then he says, well, now it's the test laptop, doesn't matter. So the customer is not helped with all these outbreaks. But in the end, it could be really interesting to see what is happening on your network, even if your alarms are classified as informational. But if there's, as a normal state, there's 10 or 20 a day, and then it spikes up into 20,000 an hour, then it might be an indication of something is happening. So what we did is, for the SOC engineers, they have these large screens in front of them. We made, this is Kibana, we made some dashboards, real-time dashboards, which is refreshed every 10 seconds, and you see all these kind of trend lines. And that could be a visual saying, okay, something is happening. And what we want to do is take that out of the human brain and put that into the machine and saying, okay, this is some kind of statistical analysis you could do better by a machine to see all these spikes and get a notification that something is happening. So you can throw out all these screens, right? So that's the enhancement we made. To give you something for the future we're thinking about is giving our SOC engineer one interface where he can have all his tickets, have some details about the ticket he's working on at that moment, have some graphs about the history of the customer or about the history of this specific threat he is working on. 2 months or 2 weeks or whatever is available or is interesting. Have a direct connection to this knowledge base, to use case with the runbook, and some real-time logs viewing what is happening at that moment. So we're investigating if it is possible to put that on top of all our systems, like Metron, like our ticketing system, like Kibana, and our data warehouse. So that's a little bit of the future. That was my part for now. So I told you about our current history, told you about the project. That's what we're standing at the moment with Metron. And Bas, he will take you into the future. Thank you.
Yes, Michiel told you already. We replaced our current architecture with which was an architecture purely based on rule-based security, and we all know this is something we cannot longer do to fight off these sophisticated attacks we see nowadays. To come up with an idea, we actually just looked at some of our customers who have like a dual vendor security policy, what we call it. And as an example of that, they run, for example, 2 different kinds of antivirus applications in the network, or they use 2 different firewall vendors at the perimeter to fight off the bad guys. So by implementing different layers or different ways to detect threats, we thought this should be a good idea, and it should give us an opportunity to help our customers in their fight against the bad guys. So as you can see, we just put them on top of each other here. Doesn't mean you go through it like this, or you can skip layers in the end. But what you see on the top layer, it's the rule-based security. That's something we already have implemented at the moment. And beside that, we want to add some extra layers like behavioral analysis, and the machine learning models, and third-party feeds. The last one, third-party feeds, we're actually already using. We use IP reputation lists to score bad IPs, and we also have some blacklist of URLs and DNS servers that we can apply in real time. The other 2, behavioral analysis and machine learning, I will cover that in the next 2 slides to give you a little bit more detail about what we're working on that way. If we talk about behavioral analysis, we kind of looked at that as a couple of entities that you can find in every customer network infrastructure. So what we see here on the left is what we call the entities. We have a user, application, server, network, and data. And within each entity, we actually want to define a couple of profiles. So for the user, we want to keep a track of his active hours that he is on the network. By establishing all these baselines per profile, we can start detecting outliers in real time. So what we basically do in real time, we're going to keep track of the active hours per user, and we also can use this information straight away in real time to see if a user is still behaving as the way we expected. We have these 5 entities written down, and you can do some outlier detection per entity, but we want to go one step further, and that's actually looking over the entities, so looking for relationships between the different entities. This should help us to detect more in a more reliable way. For instance, if we keep track of a user's activities, and someone is always working on Monday and Wednesday, and now he just switched days and he's working on a Friday, probably it's nothing, but if you would keep trigger an alert, send it to SOC, they probably will investigate it and they will end up it's a false positive. So what we can add on top of that is looking for relations. So for instance, keep the user in mind with active hours, but we also put data in there. So let's see what kind of data he's using at normal behavior. So for instance, a person is working on Monday and Wednesday, and he's normally using financial data. When he uses different data on different times, that might indicate something like a hacked account or misbehavior of the user, or maybe he's leaving the company and he's trying to get some data out of the company before he leaves. So it's important that we mix these different entities to get a more reliable understanding of the threat we probably can find in the network. Then we're also thinking and kind of already working on building some machine learning models. Our data science team, 2 guys are working at the company on a typo squatting model and a DGA detection. Typo squatting, you can see that as misspelled domain names, as the second one in the slide, the Google with double G. And for the DGA, you can see it as just randomly typed, generated domain names, like the last one or the first one. Normally, we detect these things by using blacklist or signature-based security with Suricata and a security feed. But then you always have to wait until someone on the internet detects the threat, share it with some company, then we can download the feed, and then we can apply it to our customers. We kind of want to change that around and look for a more proactive way of helping out the customers and protecting them. So by using machine learning, and particularly these 2 models, that can help us finding malware or botnet attacks. Because these kind of things, misspelled domain names and typo squatting, are used mostly for botnets and spreading the malware. It was a journey of almost a year until where we are at now, and we're kind of looking at almost going live and migrating or onboarding the first customers. And it was a year we learned quite a lot, and I want to cover a couple of these points, and the next slide will kind of summarize a couple of high-over bullets that are kind of takeaways for you guys to think about it and maybe make not the same mistakes as we did in the last year. The first one, we had a tendency to gather lots of data, and we were not really specific. Customer just asked us, can we just connect this log source, and can you do some security on top of that? That was kind of, sales always would say like, yeah, sure, just pay for us and we do something with it and we'll make it happen. For us and the SOC engineers, it was always a really challenge to get to know and understand what this log source is about, what kind of events we can find in it, and how we can utilize it to detect the detectors, what Michiel was talking about, and building up this whole layer to the top. So what we came up with was asking the data science guys to help out and say like, okay, can we build some analyzing tool that we can just feed some data and analyze the data and then come up with some report or an overview from what kind of categories and labels we can find in this log source. If we then would use the same categories and labels on the directives, detectors, and the signatures we have, we kind of could see the connection and say already straight away, hey, we see these labels appearing in this log source. We have these detectors with the same labels. So we can quite easily tell already, hey, if we connect this log source, probably it can help us detecting a couple of threats. The second one is benchmarking the whole pipeline. Michiel talked about we have a pipeline. It starts at the probe site where we collect the data. We ship it to our platform in our data center. We do some magic stuff with it. And we report back to the SOC or to our customer. What we kind of not did at all was benchmarking each component separately. So the probe, the shipping of the data from the customer side to our side. We didn't really put any attention to benchmarking Metron and also on the output layer. So when we started a pilot in November last year, we asked some customers if they want to participate in a pilot, and we connected up to 3 customers, and we had massive stability issues and performance issue. And in the end, after I think it was 2 weeks, we had to call off the whole pilot and back to the drawing board in terms of getting the stability right and getting the performance right for the plan we had. Because in the end, we are building it to onboard at least 25 customers in the upcoming year, and we should speed up that later on. After we did the benchmark, we learned quite a lot about the whole platform. So what we did is just benchmarking each and every component separately and add more components. And every time when the slowest appeared, we put some focus on it, tweaked it accordingly, until we got the whole pipeline operating the way we want, stable, and also the performance we were looking for. So it was really good information we got out of it, but it also was like a little bit of delay in the project in the end. So that's kind of a hard lesson we learned by just going straight into development, looking to add more features and make everything happy. But in the end, it's quite disappointing when you have to call off a pilot and say like, okay, we have to go back to the drawing board and we have to make some changes to also hardware, but also software configurations. The last one is data visualizations. Michiel talked already a little bit about it. Basically, we are kind of going back and forward what we have to do with the data. Our SOC engineers are having a little bit of trouble to telling us exactly what they want to see on their dashboards. We have lots of tools in our environment. We can do dashboards, we can reports, we can do real-time search with Kibana, we have Zeppelin. But we're kind of going back and forward between all the tools, and nothing is the perfect way, and that's what Michiel already talked about. It's kind of looking into a self-built application where we can have everything together, from a kind of a widget with real-time search, a widget with the overview of the tickets they have to pick up, asset information, customer information, but also historical information about assets, and everything together in just one overview. The takeaways that we want to give you from our perspective, what we kind of did, and we already were hoping for it a long time ago, but we were kind of stuck with the old architecture, what didn't innovate for us, and we couldn't really do anything on top of it ourselves. We moved kind of on a risk-based security model, from a technical rule-based security model to a risk-based. So we can talk also to people at C-level in our customer about the importance of putting security on their agenda. This was only possible because of the tooling we selected, like the open source tooling from Hortonworks, to give us the opportunity to innovate and put our own ideas in how we want to do security and how we want to help to protect our customer. In this way, we were always also able to move away from on the silos Michiel talked about. So for every customer, we have this silo. We have now one platform serving multiple customers. We have centralized configurations, and we automated another couple of things like installing and deploying the probes. If we look at the scalability, it's kind of what you get for free if you start looking in big data. Most of the tools, they already have that built in. You can utilize it, and we just have one platform, all the customers, and it kind of doesn't matter how many customers and how big the success will get in the end. On top of that, if we land all the data in two different platforms at the moment, Elastic and HDFS, we're kind of going to create a data lake around our data. So it's more data-centric, and we can start trying to pull in different sources from inside our company, maybe from the customers, to get a combination of all this data and look for more business drivers, for other insights within the data for the customer. And that should be it for this talk. Are there any questions? Nope. Ah, 1, 2, 1.
How are you using Apache Metron? So what does it offer for you?
What it offers for us? If we're just talking basic, it's the whole security engine we use, from parsing the data to get it understandable, to enrich it in real time with extra sources we pull in, until detecting threats, like rule-based, but also applying the machine learning models, the profiles we want to put on top of it. So that's kind of what it brought us technically. If we look at for the company, that's kind of the takeaway. We were able to build a platform that is scalable. We can innovate on it, and we can put our own stamp on top of it, like this is the way how we want to do security. Or if we get pushed by customers like, why you're not doing it this way, then we can have an answer on that. So I think that's the two ways we can have, that's actually the success, I think, from using Apache Metron. Yep. Somewhere there? Yeah. Part of our own infrastructure, which is built on top of it, we also push it through our own system. That's part of how we can keep in control if we are safe ourselves. It would be a little bit stupid if a security company doesn't have everything perfectly in order. The other way is we also use extensively vulnerability scanning, and that's something separate from this platform. But I think it's a good question. I will really take it back and see if we can do more, because good point actually.
How have you found the move from the traditional rule-based method that people are very familiar with, through to the kind of the full behavior analytics and explaining, like, you don't necessarily need all these thousands of rules anymore? How have you had that discussion?
Yeah, we had that discussion. SOC engineers are seeing it as a little bit scary, because they don't really feel that they're in control anymore, because they have the feeling that they don't know what kind of threats we can detect. So there's more analyzing to do before you know exactly what is happening with behavioral analysis, because just saying a user is behaving oddly, yeah, you can say that to the customer, but then you say, yeah, so what's the risk? What can you tell me more about it? So they're kind of scary for that, and we saw that, I think 1.5 years ago when we tried to do some outlier detection with machine learning. And based on the models, we found outliers, and we just gave it to the SOC engineers. But in the end, we were not able to report it with a good story around it to the customer. Yeah, it's an outlier, but we don't really know and understand what's the risk for your network or for your business. So what we kind of hope is to make it a little bit more understandable, because outlier detection, you can make it as complex as you want. We hope to make it a little bit more understandable and easier to use by calling out these entities and the profiles. So you kind of already know, like, if you get an outlier or if you get something, an entity that's behaving odd, you already know why and what is behaving odd. The only thing is, yeah, you have to analyze it and see if there's really a threat in there. And that's going to be, I think, a little bit harder. One thing we can add there is that the security engineers are not data analysts. And that's also a thing that's going to be a hard one, I think, in the end. Because they don't really know how to use data to get the right insights or get the idea around it. So that's going to be a complex one in the end. Yes? Last one is easy. We have everything on premise. We don't really have the intention to move to the cloud at the moment. The other one we are having, we did a proof of concept early this year, because we also see that all our, not all, but many customers and potential customers are moving the infrastructure or fully or partly into the cloud. And so far we always did security monitoring on premise infrastructures, and now that's moving away. What we kind of see is that if we do security on premise, then we capture a lot of network data which we can use to analyze threats. If you go into the cloud, what you see, it's more application-based log events, and we don't see any chance to keep working with rule-based security on logs like that, because if we look, for instance, for a Salesforce cloud application, when someone logs in, yeah, then he will report, yeah, this user logged in. Yeah, we can write a rule on that he should not do that after 6 o'clock on Monday. But if we have to do that for I don't know how many customers, then we're going the wrong way, I think. And that's, I think, where behavioral analysis comes in to get more security out of application logs. Yep. I think time is up. Yep. Thank you, guys. Enjoy your day.